Welcome back, everybody, for another deep dive. This time we are diving into the world of ultra-thin nanosheets. Specifically, we are looking at some exciting new research coming out of Nagoya University in Japan. Their paper, published in Nature Communications, details a new technique for making these nanosheets that could have some pretty big implications for green energy technologies.
Yeah, this is some pretty cool stuff.
So I gotta be honest, when I first saw the title of this paper, all I saw was nanosheets and metal oxides. I'll be honest, I was pretty intimidated.
I can imagine.
But then I got to the part about the researchers describing the crystals they used in the process as beautiful under a microscope. And I thought, okay, maybe there's an art to this nanotechnology after all.
Oh, there definitely is. And the elegance of this new method is a big part of what makes it so exciting. So to really appreciate the breakthrough, we need to first understand why metal oxides are so important. They're absolutely crucial for things like fuel cells, which of course are a big part of a sustainable energy future. But the traditional methods for making nanosheets out of these materials were just too limited.
Right, and that's where these surfactants come in. As I was reading this paper, I was thinking about how surfactants are already used in tons of products like soap and laundry detergent. So what makes them so special in this case?
It all comes down to how they interact with metal ions. Picture them as molecular choreographers arranging these ions into precise formations. They start with a solid-state surfactant as a kind of scaffold. Then they add water. And that triggers a process called hydrolysis.
Hydrolysis, right. That's where water molecules break down other molecules.
Exactly. And this is where things get really interesting. Older methods just couldn't control this hydrolysis process precisely enough to reliably create nanosheets from a lot of metal oxides. But with this new surfactant method, they can. It's much more controlled and efficient, and it's letting them work with all kinds of materials that were basically off limits before.
Okay, so they've got these ions all lined up thanks to the surfactants and a bit of H2O. What happens next?
Well, think of it like building with molecular Lego blocks. The hydrolysis process creates these tiny clusters of metal ions. And then they add a solvent called formamide. This acts like a master builder. It guides those clusters to assemble into those sheet-like structures we were talking about before. And it's all thanks to the shape of those initial surfactant crystals.
Wait, so you're saying we can basically make nanosheets by dissolving metals and then carefully guiding the reassembly. And all of this is happening on a scale that's 1,000,000 times smaller than a human hair.
It's pretty remarkable, right? And what's even cooler is that this technique isn't just limited to a handful of metals. They've already made nanosheets out of gallium, aluminum, and even rhodium oxide, materials that were super tricky to work with before. It really opens up a whole world of possibilities for designing materials with totally custom-made properties.
So it's like we suddenly have this incredibly precise nanoscale toolkit at our disposal. Okay, I am starting to understand why this is such a big deal. We went from me feeling totally intimidated to me being completely blown away in just a few minutes.
And that's just the beginning. The real game changer here is that these nanosheets aren't just thin, they're also amorphous.
Amorphous. Doesn't that mean they're kind of messy and disordered? I always thought scientists wanted things to be neat and perfectly structured.
You would think so, right? But that's what makes this research so counterintuitive and exciting. This lack of order turns out to be a superpower when it comes to things like catalytic reactions.
Hold on. So you're telling me that imperfections are actually a good thing in this case. Just to remind me, can you quickly explain why those catalytic reactions are so important?
Sure. They're basically the key to tons of chemical processes, including those in fuel cells, which is where this research really gets interesting for our clean energy future. You can think of a catalyst like a facilitator. It speeds up those reactions, but it doesn't get used up in the process. And when you have an amorphous structure like this with lots of defects and irregularities, you essentially have way more active sites where these reactions can happen.
More active sites means more catalytic reactions. Okay, I'm following you so far.
Okay.
But help me connect the dots here. How do these super efficient amorphous nanosheets translate into a better fuel cell out in the real world?
Well, remember, fuel cells are all about converting chemical energy into electrical energy. And those conversions happen through those catalytic reactions we just talked about. So if you can make those reactions more efficient, you end up with a more powerful fuel cell.
So I could be talking about fuel cells that are smaller, lighter, and more powerful. Where do I sign up?
Exactly. And when you think about the bigger picture, this could be a game changer for all kinds of things, from electric vehicles to portable electronics. Imagine your phone staying charged for days on a single charge because the fuel cell inside is that much more efficient.
Okay, now you're really speaking my language. But let's not forget about the environmental impact. We all know we need to move away from fossil fuels. And these more efficient fuel cells could be a huge part of that transition.
Absolutely. If we can reduce our dependence on those fossil fuels, we can make a big dent in greenhouse gas emissions. And that gets us closer to a cleaner, more sustainable future.
This is why I love doing these deep dives. We start with something that seems completely abstract. I mean, who really thinks about nanosheets on a daily basis? But then all of a sudden, we're talking about solutions to some of the biggest challenges facing humanity.
It really is amazing how these tiny scientific breakthroughs can ripple outwards and potentially change the course of history. And this research from Nagoya University is just the beginning. There's still so much more we can do with these nanosheets.
Okay, I am officially hooked. So what else are scientists excited about with this new technology? We talked about fuel cells, but where else could these nanosheets make a difference?
One really promising area is sensors. Their unique properties, particularly their massive surface area, and their sensitivity to even tiny changes in their surroundings. It makes them incredibly good at detecting things. We could be talking about sensing gases, chemicals, even biological molecules.
So like a sensor that could detect pollutants in the air we breathe. Or maybe even a device that could diagnose diseases based on your breath.
Exactly. You could see applications in environmental monitoring, medical diagnostics, even food safety. Imagine a world where you could instantly know if your food was contaminated with bacteria just by using a handheld sensor.
That's incredible. It sounds like we're on the verge of a future where nanotechnology is woven into every part of our lives.
And this research from Nagoya University has brought that future a big step closer. By developing this elegant new way to create these nanosheets, they've opened up a world of possibilities for innovation across so many fields.
It's pretty mind-blowing to think that soap, something we use every day, played such a key role in this whole breakthrough. Those surfactants are the unsung heroes of this story.
It just goes to show you that scientific discoveries can come from the most unexpected places, and that there's always something new to learn, even from things we think we already understand.
Okay, so let's recap. We have this groundbreaking method for creating amorphous nanosheets from a variety of metal oxides. They're incredibly thin. They're packed with defects that actually make them more efficient. And we can even customize them by combining different metals. It's like we have a molecular construction set for building the future.
You got it. And as we continue to explore the possibilities of these materials, who knows what other amazing applications we'll discover. More activity, more efficiency.
Okay, that makes sense. More active sites, more catalytic reactions, but I still feel like I'm missing something. How do these super efficient amorphous nanosheets actually lead to a better fuel cell in practice?
Well, you just have to remember that fuel cells are all about converting chemical energy into electrical energy, right?
Yeah.
And those conversions happen through those catalytic reactions we were talking about. So if you can make those reactions more efficient, you get a more powerful fuel cell.
So theoretically, we could have fuel cells that are smaller, lighter, and more powerful.
Yeah.
It sounds amazing.
It really does. And it could have huge implications for everything from electric vehicles to portable electronics.
Yeah.
Imagine if your phone could stay charged for days on a single charge just because the fuel cell inside is that much more efficient.
Now, that's something I can get behind. And we can't forget about the environmental benefits either. We all know we need to transition away from fossil fuels. And more efficient fuel cells could be a big part of making that happen.
Absolutely. If we can reduce our reliance on fossil fuels, it would significantly cut down on those greenhouse gas emissions. And that brings us one step closer to a cleaner, more sustainable future.
This is why I love these deep dives.
Yeah.
We start out talking about something that seems totally abstract. Like, honestly, who goes around thinking about nanosheets every day? But then suddenly we're talking about solutions to some of the biggest problems facing the planet.
It really is remarkable how these seemingly small scientific discoveries can have such a huge impact. And this research from Nagoya University is really just the beginning. We've only just scratched the surface of what's possible with these nanosheets.
Okay, you've definitely got my attention. Besides fuel cells, what else are scientists excited about? Where else could these nanosheets make a difference?
One area that's generating a lot of buzz is sensors. Because of their unique properties like their massive surface area and their incredible sensitivity to even the smallest changes in their environment, they're really, really good at detecting things. We could be talking about sensing gases, chemicals, even biological molecules.
So we could have sensors that can detect pollutants in the air or maybe even diagnose diseases based on your breath.
Exactly. The potential applications are huge. Environmental monitoring, medical diagnostics, food safety. Imagine a world where you could instantly know if your food was contaminated just by using a simple handheld sensor.
That would be game-changing. It feels like we're on the verge of a future where nanotechnology is integrated into every aspect of our lives.
And this research from Nagoya University is a major step in that direction. By figuring out this new elegant way to create these nanosheets, they've opened up a world of possibilities for innovation.
And to think it all started with something as simple as soap. Those surfactants really are the unsung heroes of this story.
It really highlights how scientific breakthroughs can come from the most unexpected places. And it's a good reminder that there's always something new to learn, even from things we think we already understand.
So to sum it all up, we have this groundbreaking method for creating amorphous nanosheets from various metal oxides. They're incredibly thin. They're packed with defects that actually make them more efficient. And we can even customize them by combining different metals. It's like having a molecular construction set for building the future.
I like that analogy. And as we continue to explore the possibilities of these materials, who knows what amazing applications we'll discover next.
Yeah, it really does feel like that, doesn't it? Like
Yeah.
we've stumbled into this whole new world of possibilities at the nanoscale.
And the most exciting thing is that we're really just getting started. As researchers refine this method and start experimenting with new combinations of metals, who knows what other incredible properties they'll discover. We could see nanosheets with even greater catalytic activity, enhanced electrical conductivity, or even unique magnetic properties.
Okay, so let's bring this back down to earth for a second. For our listeners out there who might be wondering how all of this incredible science will actually impact their lives, what's the big takeaway? What should they be paying attention to as this technology develops?
I think the key takeaway is that we are witnessing a revolution in material science, and it's all being driven by these ultra-thin nanosheets. This isn't just about making small improvements to existing technologies. We're talking about creating entirely new possibilities.
It's like we're not just upgrading our toolbox. We're discovering a whole new set of tools that we never even knew existed.
That's a great way to put it. And the implications are huge. We already talked about more efficient fuel cells, revolutionary sensors, and even advancements in medicine. But this technology could also transform fields like electronics manufacturing and environmental remediation. Imagine nanosheets being used to create ultra-efficient solar panels, or even to filter pollutants directly from water.
It's a future that's both incredibly exciting and a little bit intimidating at the same time. This technology has the potential to solve so many of the problems we're facing. But it also raises some important questions. How do we make sure these advancements benefit everyone, not just a select few? And how do we anticipate and mitigate any potential risks as we start integrating nanotechnology more deeply into our lives?
Those are really important questions, and they're ones that we need to keep asking as this technology continues to evolve. We need to approach these advancements with a balance of enthusiasm and careful consideration, making sure that we're using them ethically and responsibly to build a better future for all.
Well, I think it's safe to say that this deep dive has left me with more questions than answers. But that's not necessarily a bad thing. It's sparked a real sense of wonder and possibility, which I think is ultimately what makes science so captivating.
I completely agree, and that's what we hope our listeners take away from this episode. The world of science is full of unanswered questions and mysteries waiting to be unraveled, and even the smallest discoveries can have a ripple effect that changes the world as we know it. So stay curious, keep exploring, and never stop asking questions.
And who knows, maybe one of our listeners will be the one to make the next big breakthrough in nanosheet technology. All thanks to a deep dive they listened to years ago.
That would be incredible. But until then, keep diving deep, everyone.
We'll see you next time.